Hello, in this opportunity I will explain quantifying the environmental impact of vehicle emissions due to traffic diversion plans, case study, bridge construction project in Chongqing, China. Author are Mingyong Ma, Ming Liu, Xichao Li, 2023. As an introduction, we have that the global priority is mitigating greenhouse gas, GHG, and pollutant emission. China's goal is to reach carbon peak by 2030 and carbon neutrality by 2060. As any other developing country, urbanization in China leads to increased population density, land use expansion, and urban transportation demand. 13.7% of China's energy use in 2016 corresponds to transportation. Traditional LCA models often overlook emissions from traffic diversion. Temporary road closures from infrastructure projects worsen urban traffic, leading higher emissions. Higher emission occurs during transition between free flow and congestion. At the same time, emission rates depend on speed, acceleration, and deceleration. The objective of the article is to propose a method to quantify environmental impact of traffic diversions using a real-world case in bridge construction in Chongqing, China. The LCA Life Cycle Assessment, ruled by ISO 14044-26, Environmental Management LCA. A methodology overview, we have that they use copper B among other models to estimate 10 pollutants based on the vehicle speed and mileage. Why they choose copper B chosen for suite for Chinese vehicle fleet, effective under congestion traffic conditions, and ruled by Euro 5 standard. The environmental impact evaluation used Recipe 26 method as an impact assessment, midpoint and endpoint indicator. And we can see in the figure 1 some inputs like fuel and the proceeds that are the models and the road closures to construction lead to outputs that 10 pollutants, and also the life cycle impact assessment. We have the midpoint and endpoint. The endpoint we have human health and ecosystem. The study case are 4 traffic diversion plans analyzed for a 210 days bridge construction. The 4 diversion plans affected 7 major roads. Roads diverted traffic using 2 alternative bridges and multiple urban roads. The data collected was the vehicle flow, speed, road length and saturation, and peak hour traffic. And we can see in the figure 3, they show us the different roads and bridges will be used. The article has some assumptions like only gasoline passenger cars, LDGV, and average community mileage of 100,000 kilometers, speed to 10 to 50 kilometers per hour based on congestion level. The results. As the key finding in emission impact, we have the pollutant differs in each plant, and being the worst, the plant D with 610.34 kilograms of CO2. And in the environmental impact result, we have the global warming dominant in all plants, the CO2 greater than more than 94% in all cases. In human health, in simple words, the exposure to the pollutant makes us lose until 32 days of life. In the ecosystem, a simple word, one species is going to be extinct every 3,134 years. We can see in the right that each plant in human health are predominant with global warming. In the sensitivity analysis sample method for variance sensitivity, use 6,000 samples generated based on the input parameters like speed labor, speed before, speed during, distance, etc. The main finding, traffic speed during construction is the most influential factor in overall environmental impact, as we can see in the figure 6. And other factors are road length, road capacity, and community mileage. The discussion highlights traffic diversion significantly affects urban air quality. and should not be ignored in the LCA. Even small scale changes like road choice can impact in public health and ecosystem, more in public health. And we can see CO2 emissions are tightly linked to fuel consumption, a strong case for clean transport. Electric vehicle adoption is a promising mitigation path. In the figure 7, we can see that China hopes to reach 75% of electric vehicles in 2050. As a conclusion, we have that develop a practical method for assessing environmental impact of traffic diversion plans. Diversion plans with better traffic flow result in significantly lower emissions. Urban planners and engineers should include traffic diversion impact in early stage planning, optimize routes based on emission and health impacts. As a future work, incorporate driver behavior, vehicle type, and real-time traffic data. See the reference, and thanks.